This maths department in Cambridgeshire is experimenting with using games and number puzzles as part of their whole class teaching, and with a range of abilities. Teachers at Comberton Village College start their project by doing some maths.
How many different quadrilaterals can be made by joining the dots on the circle? Oh, crumbs, we don't have enough.
They're trying out a selection of enrichment activities for themselves.
This is fun.
I'm doing crossed ends. If you draw a cross, the north end plus the south end is going to equal the east end plus the west end.
I'm looking at the one which is called dozens, where you have to try and find the largest possible 5-digit number that's divisible by 12.
I'm going to work out the angles in the centre by thinking what fraction of the circle it is.
3527.
Traditionally, these mathematical games and number puzzles are used with higher attaining students or in maths clubs. But the maths department here is seeing if they can use them in their normal teaching and with a wider range of abilities.
So thinking about, I'm going to waggle my biscuit, you know, thinking about the way you're introducing it, I mean, you could, even a bottom set year 7, I think, could cope with this to a certain level.
Year 7s who are really struggling with maths, they could access that task, but they wouldn't get up to the angles, perhaps, apart from a few of the special quadrilaterals.
It would be a very valid task without accessing the angles at all.
They also have to have all the vocabulary in their pockets before they start all of that, so they can communicate about this effectively. I mean,
or the other way would be if they don't have the vocabulary, they'll then be struggling for the words, and that's a good way for them to learn them, because then you can say, well, then you can work with them to develop.
Once they've assessed the activities, they try them out with their students.
it's okay. Can we do another one? Can anybody draw another one for me?
This activity is about creating different quadrilaterals by joining points on a circle, with maths teacher Asnat Dozer.
I was trying the same activity with two different groups, a very high attain group and a lower attain group. My objectives were completely different for both groups.
We're just counting how many shapes that we can find within the circle.
Asnat gets her top set year 8s to work out how many different quadrilaterals they can create on an 8-pointed circle.
There's like 12 that can be done, isn't there?
Yeah.
Or more even.
Oh no, that'll be confusing. No, that won't work.
Because then if you mirrored it, would it be a different shape?
Flip it the other way around. Yeah, that would be a different shape.
Because if you turn this upside the other way round, it's this shape. But if you switch it around again, it'll be a different shape.
What happens if you flip it over? Is that the same?
I don't know.
Yes.
It probably is.
Can you rotate it to get back there?
I wonder.
Among the discussions, some theories begin to emerge.
Yeah, you can.
We're not doing rotation. We found 8 quadrilaterals, so there's 6 there and 2 here. We found out 8 that can be made, and we're trying to work out a theory of, and we're looking at the dots. So like, there's 4 left over here. Then there's 3 on these 2, and it's because the 3, and then the third one could be that one, which we've got there.
So, there seems to be a connection between the number of different quadrilaterals they can make and the number of dots on the circle.
4 points gave us 1. Cross that one out. We don't want to count it in. So 4 points gave us 1.
No, 5 gave us 1.
4. No, 4.
It's 5.
5, yeah.
Oh, and 4.
5 gave us 1.
Yeah, but
6 gave us 3. And 8
given us 7. So it'll be 5, 1, 1, 1.
The amount of ideas that came out of this group was really overwhelming, and each one of them was worth exploring in many ways, and I would have liked to have more time to work with them. I mean, we had some students asking for a 9-dot circle, and I thought, they said, do you have one? Because we think we found a general rule. How about Miss?
With her lower set year 8s, Asnat tackles the same activity in a completely different way.
What can you tell me about the shape I just made? Adam?
It's a quadrilateral.
It's a quadrilateral. What is a quadrilateral?
4-sided shape.
A 4-sided shape. So look carefully at this quadrilateral. I think the idea was, instead of making it completely abstract in mathematics, to give them some sort of kinesthetic activity, if you like. I wanted them to be able to start the discussion without talking about dots and circles, but talking about themselves. So move the string from Jeremy to Megan is the way that I wanted to open up the conversation, if you like. Everyone's moving 2 spaces. Oh, miss, you're in again. It's also a very visual way of doing things.
Only then does Asnat get them to work on the sheets.
We're just like drawing different quadrilaterals. That's a rectangle. That one there. That one's
Square, rectangle, that's the easy one.
That one kind of looks like a trapezium.
Yeah, it does a bit.
2 parallel lines. Do we have 2 parallel lines here?
This time the emphasis is on the students knowing the names of the different quadrilaterals and understanding their properties.
Over the other side.
Yeah.
What is the name of that one?
Another irregular.
It is irregular, I agree, but it's got a name. Let's rotate the page, see if that helps. I'm rotating it slowly, see if that helps.
Does it have 2 parallel lines?
Yeah. Beautiful. It's got 2 parallel lines. Can you point to the parallel lines? That and that. These 2 lines are parallel. What does that mean, parallel?
Parallel means like if you have a ruler, they're on a straight line and it doesn't go like it's just like straight like a train track, but it just goes
Straight on. Will they ever meet?
No.
No, they'll never meet. So these are parallel lines. So we've got a shape with 2 lines that are parallel, and the other 2, are they parallel?
Parallel.
Aren't parallel.
Like that. So at the end,
they will meet, won't they? The way they were talking to each other today, I think, was amazing, because I think they all felt very comfortable that the problem was accessible to them. And they almost didn't need teacher confirmation to have a conversation. They were just having it between themselves, which was beautiful for that group. Yeah, that was sort of what I expected from the higher attainer groups. They're used to having conversation about the maths without needing me to support them. But with the lower attaining group, that was absolutely delightful. I'm so proud of them.
I've picked a number, 4-digit number, 3527.
With her Year 7s, maths teacher Suzanne Mallet is trying out a number puzzle.
Take the numbers, but I'm going to take the very first number and move it to the back. Gemma, could you do it on the whiteboard?
She then gets the students to add the 2 rearranged numbers and see if the total is divisible by 11.
Everyone else check that they're right.
As well as encouraging accurate calculations, these number puzzles can also be the basis for a whole class investigation.
Where could we go from here? We've started to see a pattern, but what could we do?
Well, we could see, because all the numbers that we've chose have totaled a multiple of 11, so we could see, is there any that don't, or does it always work, and why does it work?
You maybe could use numbers with less digits or more digits.
With more or less digits? That's a really, really good point.
So off they go, adding different numbers of digits and dividing by 11 to see if a pattern emerges.
Matthew, just worked out odd numbers of digits don't work, but even numbers do.
I've tried 1 and 8 digits, and one of them worked, but I'm trying another one right now. I'm not sure it's going to work.
Yeah, and 38 digits rather hard, but I'm so determined to do it.
So there's A and B, and say you have A times 10 plus B.
Yeah, because the A is in the tens column.
Yes, and then if you kind of swap them around, it's 10B plus A. And when you add them in all, it's 11A plus 11B, so it's always a multiple of 11.
One interesting thing or fact that you found?
We were looking at the different numbers, and our group are looking to see we worked out the 2 digits work, 3 don't, 4 do, 5 don't. So we thought there's a pattern there, and the even ones seem to work and the odd ones don't seem to work, so we're still checking things like 7 and 8.
That's fantastic. Well done, you.
We were using algebra.
When it's pupil-led, they're becoming more creative with how they approach these problems. And also when they're kind of deciding what to do, they were becoming more engaged with the task. Because I found some of them were enthusiastic and chose a 38-digit number, and that took them the whole time to add one 38-digit number to another and then divide it by 11. But that's fine because they're checking their arithmetic and they're checking how to divide very long numbers and also check that they're doing their calculations carefully. So that was one thing that came out of it. Some people started to talk about generalising, and it was also very nice to kind of have them at the end kind of sharing their ideas and going, oh, actually I thought of that too, or ooh, didn't think of that.
We did 4 consecutive numbers, and when you times the outside 2 and the inside 2, the difference is 2.
Number of consecutive numbers.
These Year 9s are looking at strings of consecutive numbers and the difference between the product of the 2 outside numbers and the 2 inside numbers.
Now, what I'm going to ask is, I'm going to ask tables to just give us a bit of feedback as to what they...
Maths teacher Jonathan Love uses this activity to get his students thinking about generalisations and proof.
OK, so you put a 7 on the end, yes, and then what happened?
And we got a difference of 4.
You got a difference of 4. OK, so then Hal said that he came out with some sort of rule at the end. What was the rule that you came out with?
The amount of consecutive numbers minus 2.
The difference between the outside product and the inside product?
Yeah.
Was the number of consecutive numbers take away 2. Is that what you've discovered?
Yes.
How can you be so sure that this works for all sets of consecutive numbers? How can you be sure?
Can't you just try like loads?
We could.
Oh, you can do something like with the n, like it'll be like a formula or something.
It should be like a formula or something.
So we've got our consecutive numbers, and the first one was A.
And soon, an algebraic proof begins to emerge.
So it's a squared at the front.
Yeah.
Plus 3a
Yep.
plus 2. Now that is what a plus 1 times a plus 2 equals.
So that's the answer.
That is the expression for the product of the middle 2 numbers.
Then we have to find the difference up between them two.
Well done, Leanne.
Oh, I see, it's going to be 2.
Because?
3a take 3a is 0, then a squared plus take a squared is 0.
No, explain it to Yuki because he wasn't listening.
Right, Yuki, basically, right, you get a and then a
Tom, you're
plus
listening?
3,
I'm listening,
and
yeah.
that makes a squared plus 3a, so you have to take them away from each other, which leaves you with 2.
You take that away from that.
So,
Oh, okay.
So you take away 3a from each side.
Yeah.
It's
Oh, yeah,
a
yeah.
squared by itself, then a squared plus 2.
so if you have 4 numbers,
Yeah.
does it matter what your A is?
No.
Yeah.
Does it matter?
No.
Could A be... What numbers could A be, Yuki?
3.
Any number.
Any number.
Activities like this really help the pupils' enjoyment, really, because they're starting to engage on it and taking ownership for it. It's not just teachers standing at the front and telling them what to do.